Okay, it's the structure of an atom or the atom. Now, this will talk about different parts of the atom and all that other fun stuff to go along with it. And as usual, when I am going over a tutorial, I typically won't answer the questions on the tutorial. I'll let you do those on your own, or I'll answer it if I think it's important and goes along with the tutorial or the lesson. And a lot of the times I'll let you watch the videos on your own as well. So let's get into this. It says you will compare atoms and with respect to the subatomic particles they contain. Now, I have a lot of other little mini lessons where I've talked about electrons, protons, neutrons, atoms, elements. I've dove into the periodic table, isotopes and ions. There's a lot of other mini lessons, so that breaks it down just a little bit more. So first, let's see, it says the smallest unit, so atoms, the smallest unit of a chemical element that still has the chemical properties of that element. Now, again, let's skip the intro video. History of the atom. So these are just different models of the atom. So the modern atomic theory developed through the contributions of different scientists over many centuries, meaning it took hundreds of years, many centuries, hundreds of years, to develop different theories, different models of the atom. So way back, let's see, right around this time period, it says 400 BC is kind of when things first started to develop around the atom. So if we click it, it'll give us a little bit more information. Let's go this way. 400 BC, this tells you this Greek philosopher was the first to discover the purpose theory of atoms. So then he's telling that he's arguing and telling that objects could be divided into smaller pieces until they couldn't be divided any further. So he has first started this theory on atoms, gets it going. Then all the way 1803, so hundreds and hundreds of years later, thousands of years later. Then John Dalton, an English physicist and chemist born in 1766. So he started the modern atomic theory. So first 400 BC, it starts. He's talking about the theory of atoms here, and he's arguing again that things could be broken down, and then John Dalton, thousands of years later, thousand-ish later, then he's talking about the modern atomic theory, and here, law of conservation of mass. And I do have that in a mini lesson as well, the law of conservation of mass, and it breaks it down even further. Then 1897, J.J. Thomson, who studied physics and mathematics, discovered the existence of electrons. So then it goes even further, then we find the electrons in the atoms. So that's what he detected. Then even further in 1911, we have Ernest Rutherford, and he's a physicist from New Zealand. And then he took J.J. Thomson's, he was one of his students, and then he discovered the mass of the atom. So he took that and went even further. So then the history of atoms, it's being studied for a couple thousand years now. So 2000, let's say about 2000-ish years, I'd say. And he's now this guy is designing the atomic model. Then 1913, then now we're getting into more detail about, okay, electrons didn't fall into the positively charged nucleus, but why? Okay, we know that they're negatively charged. 1926, it goes even further. So then now we're going even further with the atomic model here. So this just gives you a basic history of atoms and what's going on with those. So early discoveries, again, more information. Hydrogen was one of the first elements to be discovered, and that I have another little mini lesson on just hydrogen. But first, let's talk about elements. So an element, a substance that cannot be separated into a simpler substance by physical or chemical processes. Compound, a substance made up of two or more chemical elements that are chemically bonded together. Okay, so this one, let's see what two laws were discovered by these guys. Law of conservation of mass and law of definite proportions. Those are two important things. Matter cannot be created or destroyed. John Dalton. He's one of probably the most well-known with the atoms due to some of the theories that he came up with. And then this just shows an atom. So here's matter, here's a molecule, then here's the atom broken down even more. So there's the nucleus, right where my arrow is pointing. Nucleus has protons and neutrons, and the electrons are on the outer, in the outer shells on the atom. But it's just showing how it's broken down even further. Okay, so then we can summarize it. We have these statements right here. So these are important. All matter is made up of small particles called atoms. Atoms cannot be created, destroyed, or divided into smaller parts. All atoms of an element are the same, but they are different from the atoms of other elements. Compounds consist of atoms of different elements combined in simple whole number ratios. Then chemical reactions occur when atoms combine, separate, and rearrange. So meaning atoms are combining, separating, a chemical reaction is taking place. So you're combining two different elements and something happens. Okay, now this just shows us the discovery of electrons as a subatomic particle with a negative electric charge. So electrons are negative, protons are positive, neutrons are neutral. Okay, and this is how he was experimenting. This is the model he used when he was experimenting, and this is how he found electrons. Pretty fancy. So let's see. I will answer this one because this will go along with one of the theories, the atomic theory. What was disproved by Thomson's experiment? What part of Dalton's atomic theory was disproved? Atoms cannot be created, destroyed, or divided into smaller particles. Meaning that with his discovery, he showed the discovery of the electron. It showed that atoms can be divided into smaller particles. There's a little room for wiggle room here because it can be divided into smaller particles like electrons. However, atoms, that's the smallest it can go. So it's not like we're dividing the electrons into something else, into something else, into something else. But it's just showing he is proving that, hey, you can divide this into like electrons. Here's the electron shells. Okay. And then here's another model for atoms. Let's go to the next one. Again, the questions, I'll let you do those questions on your own too. Here's a model of an atom. Real quick, nucleus in the middle where the protons and neutrons are again. Electrons are in the outer shells, as you can see right there. And again, here's another model of atoms. So there's so many different models of atoms that basically show you the same thing. They just depends on how they're drawn. I like to draw them with the nucleus in the middle and like circles around it because that makes more sense to me. But this makes more sense to you. Who knows? Nucleus is in the middle. Electrons are orbiting on the outside or outer edge. So this model is the model that I like the best because it shows nucleus in the middle, how many electrons are around on each shell, and how the electrons are orbiting around the atom. Okay, so let's go to, and that's Bohr's model. And I'll skip that part. I'll let you do that part on your own, those questions. And then Bohr's model again. So he took it even further and showed here the electrons are orbiting around the atom in a circular position. And I like this model of atoms too because it's a little bit less confusing. So now the atom structure, we have this right here. And this just shows us we have neutrons, protons, and electrons. And it says, okay, the nucleus consists of protons and neutrons again. Protons are positively charged. Neutrons are neutral. They don't have a charge, they have nothing. Okay, and then this shows the actual mass. And again, there's another lesson where I go over neutrons, the mass, and everything about, like, there's all other facts about it. So let's see, this tells us carbon. And here's just an example of what carbon looks like. Whoop, let me go back. And it has 6 protons, 6 neutrons, 6 electrons. And then here's oxygen and what oxygen has. And then there's a picture of potassium as well. So it just gives you an idea of how the electrons are placed in the shells. And we'll skip this one. Okay. Yep, the question. So ions and isotopes. I'll just briefly talk about this because I did have another lesson on this as well that you can refer back to that if you need to. Um, so let's go to ions and isotopes. So when a neutral atom gains or loses an electron, it becomes an ion. An ion is an atom or molecule that has a positive or negative electric charge, meaning it's +1 or -1 or something like that. So an anion is an ion that has a negative charge. Cation is an ion that has a positive charge. So these are just showing some examples. We'll skip the questions. And now the isotope. A specific type of a certain atom defined by the number of neutrons it contains, meaning that some have different numbers of neutrons, some atoms. So let's go to the next part. And this shows an example of, let's see, chlorine. And let's look at this. It shows that chlorine has 18 neutrons, 17 protons, and 17 electrons. So it's just showing that it has different neutrons in this, and then in this sentence, it's saying it has 20. So different isotopes, meaning different atoms and different atoms of chlorine, they have different numbers of neutrons in them. That can happen. It happens in carbon as well. In oxygen, here's just another example of the different numbers of neutrons it contains. And here's this. Skip this part. And we are just about done with this tutorial. Hopefully this gives you a better understanding of atoms and all that fun stuff. And I also recommend that you refer back to some of the other little mini lessons I've done with atoms and the protons, neutrons, electrons, and all that other fun stuff. And hope you enjoyed.